Hello, everybody. Happy Monday. So I'm going to go ahead and start because it's about time for us to start class. So I'm going to start. And you are moving now into the stuff that I consider is a lot more stats oriented. So you're really learning to use the tools that you've been building the foundation. So with all the terminology, and then how you describe data in terms of statistically described data, and also through numerical and through graphs. And then you also really did a lot of work learning about probability. So all of those pieces are really pulling us together now into this next chapter. So I'm hoping that you're going to feel more comfortable because you have such a strong foundation of those basic skills that we've built so far in the quarter. Today, I'm going to talk about mostly the normal distribution, and I'm going to talk about using both StatCrunch, and I'm just going to maybe demonstrate some stuff on the calculator, but I know most of you use StatCrunch the majority of the time, so I'm going to be demonstrating with that, but I will also talk about the calculator in case there's some of you that like to use a calculator, because both work really well for this section. My emphasis on this class today is giving you a visual, so really encouraging you to draw probability statements and drawing your graphs with shading so you can connect what the numbers are spitting out either on your calculator or StatCrunch. So that is my focus today. So let's get going on this. So what I've done is I have a document inside of the Zoom meeting, and that document is on 7.2 basically is what we're going to be talking about mostly. So I'm going to share my screen. Here we go. Share screen. That. Okay. Not that. Okay, so this first slide is actually super blurry. I don't know why. I just took the picture of it super blurry, but you have it in front of you. I'm just going to redo it because it's just too blurry. It's even blurry for my eyes. Okay, let me add a page in here. Okay, so come on, right, hang on. Oh my goodness. Normal distribution is what I'm trying to write. Okay, so if we're talking about the standard normal distribution, we know that that involves z-scores, where z will follow a normal distribution with a mean of 0 and a standard deviation of 1. Okay, so I'm just writing down the random variable z follows a normal distribution, and then I'm just listing the mean and the standard deviation. So that's what a normal standard deviation, the parameters that the normal standard deviation has. We know it's a bell-shaped curve where the mean is 0 in the center. And the z-scores are like a number line that's listed across the bottom. Okay, so if I'm just going to take a very short little jaunt off to the side. So if I give you this equation, you know that that is a linear equation, and you can recognize right away that it's in the form y equals mx plus b. So you know it's a linear equation. You know that the graph, because we spend a lot of time on this as well, we know that the graph will be a straight line. We know that it goes through the point 0, 1, the y-intercept. And we know the slope is 3/1. So on a very, very sloppy graph, this is what the graph looks like. And we know that just because we are comfortable with that equation, especially being in the form y equals mx plus b. So this equation creates this graph. This is like on an xy axis, and the graph that's created is this curve. This curve is created by this equation. And I know it looks really crazy because there's so many variables and symbols, but this really just depends on x and y. Just like your y equals mx plus b depended on x and y. It's just that this equation gives you this straight line. This equation gives you this bell-shaped curve. Okay, so this equation is not scary. You know a lot about what's in this equation already. You know what pi is. E you may have not learned, but it's similar to pi. It's an irrational number. So it really is just the equation that gives you the shape of this graph. So that's all that first slide is about. The second part here, if we were looking at just a regular normal distribution, so not standard normal, then we would have a random variable called x. It would follow a normal distribution, and we would be given the population mean and given the population standard deviation. We would be given all that. We still would have this bell-shaped curve. We still would have mu in the middle, the mean in the middle. And how we get to one scale to the right is we would take the mean plus 1 standard deviation. Then we would take the mean plus 2 standard deviations, and then the mean plus 3 standard deviations. We would also build the scale to the left in the same direction, in the same way. We would subtract a standard deviation. We would subtract 2 standard deviations from the mean and subtract 3 standard deviations from the mean. So this would be the scale that we would be using if we were to draw the picture, and this is what we're going to do today. We're going to draw these graphs based on the distribution, based on the mean and the standard deviation that's given. Okay, and this has a little bit different equation. I'm just not going to give it to you because it's not necessary. But these two are still both the standard normal and just a regular normal distribution. They look similar, right? They still have the bell-shaped curve, but they're not similar because the standard normal has a mean specifically of 0. And then the standard deviation is 1. So I would go out 1 unit, 2 units, 3 units. In a normal distribution where the mean and the standard deviation are not 0 and 1, it's just a normal distribution. And my variable is x, but we still have a similar shape of the graph. Okay, I'm going to expand a little bit further and then I'm going to stop. So these are things that you have learned about the normal distribution, and I'm putting it in a very general way. But what changes the shape of the distribution is what makes the peak higher versus if I did one like this. So the mean could still be the same, but what makes the difference between the peak being high and the peak being more flat? Your standard deviation. Your standard deviation, if your standard deviation is smaller, the values are closer to the mean. If your standard deviation is larger, the values are more spread out. So the curve will be more flat when the standard deviation is big because the values are more spread away from the mean. If the standard deviation is small, then the values are going to be close to the mean. So it's going to pop that peak up. So that alone makes the different graphs because we might have the same mean, but the standard deviation can change how flat or how tall the peak of your graph is. Okay, one more picture. Let me just, I guess I should write this. Small standard deviation indicates that the peak will be higher because the values are closer together. The data values are closer to the mean. If the standard deviation is large, then your peak will be more flat because they're spread further from the mean, the data values. Okay, so the next graph I'm going to draw here is so I'm trying to get those to look like the same shape. So they have the same spread. So therefore the standard deviation would be the same, but the mean, and I'll just do mean sub 1, mean sub 2. So the means are going to be different. The mean for the blue is here. The mean for the orange curve is here. But the height of the curve, the spread of the curve is the same. So here the mean is different. But the standard deviation is the same. So I'm spending time today to talk about this because I think the visuals help you connect what you're just clicking on in StatCrunch and what you're doing in your homework as well. Okay, that's all I wanted to expand on with that part of it. Now, the worksheet that I gave you, it says in there that we're going to find these probabilities, or not probabilities, well, yeah, they actually are probabilities. So we're going to find the probabilities by just technology. I'm not going to do it by hand. No, I'm not doing that. I'm going to show you by the calculator and by StatCrunch, 2 ways there. I am going to have you draw the diagram, but I'm not going to do anything by hand or with the table. I would recommend that you avoid using the table. The table with when you're changing into a z-score and then you're going to use a table, I would recommend entirely avoiding the table. You have technology right at your hands, and it's going to be definitely more effective, more efficient, more accurate if you rely on your calculator and the StatCrunch. So I'm going to demonstrate all of that from here on out. Okay, so this is the first problem. Draw the diagram and shade the indicated area. Okay, so I'm going to draw this diagram. It's a normal distribution. And since it's a z, right, it says z right here, z equals 2.14. I'm going to mark that on my graph. So I'm going to put the scale for z-scores, 1, 2, 3, -1, -2, -3. That's the scale for z-scores. I'm going to take my 2.14 and I'm going to mark it on my number line. So that position is 2.14. Okay, and then it's asking me to shade the area to the left of that z-score. So from the number line, draw your line up to meet the curve and then shade the area to the left. Okay. Let's do the same thing for here, and then we're going to come back and find the probabilities. Okay, so area to the right, negative 0.17. So I'm going to draw my diagram here. We're still looking at z-scores because it says z equals. So put your scale on. Negative 0.17. Okay. Okay, so a little bit to the left of 0 because it's negative. So then I'll draw a straight line from the curve to that position on the number line, and it's asking me to shade the area to the right of that value. Okay, so I'm going to stop here and we're going to get the probabilities now. So I want you to look at part A. Part A is this first curve. I know that the total area under the curve is 100%. So this is definitely more than 50% because 50% of the area shaded would be at 0. So it's more than 50%. I would say it's more than 70%. So your visual of the graph is making sure that when you're punching your numbers into StatCrunch or the calculator, that you're getting something that is reasonable. So in your calculator, you would go to, okay, so it takes me a minute to flip back and forth between sharing my screen with the computer and sharing my screen with my iPad. So I'm going to stick with the calculator and then we'll go into StatCrunch and we'll do all these in StatCrunch. Okay, so the calculator, you would go under second vars. So go to hit your second button and then hit the vars button. Second in vars, and then you're going to go to normal CDF. This is number 2. Okay, and then you're going to hit enter. So when you hit enter, you get a menu on your screen and it says lower, it says upper, it says mu and sigma, and then paste. Okay, so your lower is what is the number that's furthest to the left, and then the upper is what is the number that's furthest to the right. So looking at the boundaries of the area I'm trying to find, so the area is matching the probability. The area I'm trying to find is from negative infinity up to 2.14. So I'm going to know that my upper is 2.14. And I don't have a negative infinity on my calculator. So the way I tell the calculator a really small number is I do -1 E99. So this means it's like scientific notation. Remember we learned that means scientific notation on our calculator. -1 E99 really means -1 times 10 to the 99th power. Okay, so this is really -1 times 10, and then you'd have 99 zeros behind that -1. So that's a super small number. Okay, how do I get that on my calculator? I put in my negative sign. So make sure that you're putting in negative, not subtraction. So type in your negative and then you put a 1. Now the way you get the E is you would go to second comma. So this E right here, you hit your second button and then you hit the comma button. Right above it has like 2 E's on it. But that's how you find, that's what the scientific notation button is. So second and then hit the comma button and then put your 99 in. Okay, and then the mean for standard normal, so mean for z-score is 0 and the standard deviation is 1. So 0 and then 1 and then hit paste and we get this. So on your screen it looks like this. On your screen you'll have normal CDF and then you'll have -1 E99. So lower bound up to 2.14, the mean and the standard deviation. So that's what your screen's going to show. And when you hit enter, I didn't put that in right, so hang on. Okay, when you hit enter, you get approximately 0.9838. Okay, so that's the area that's described, that's shaded in the red. That's the area to the left of 2.14. Let's try that with the second one. So the second one, area to the right. So we're still going to go to second VARS, normal CDF. Okay, and then your lower bound. So I'm reading the graph like I'm reading a book. So lower bound would be negative 0.17. Upper is positive infinity. So on your calculator, after you get to, when you go to the normal CDF, your lower is negative 0.17. The upper is positive infinity. So I'm going to put a positive one in E99. And then you'll have the mean. You'll have mean and you'll have standard deviation. So the mean is 0, standard deviation is 1. So you get normal CDF. And then negative 0.17, 1E99, 0, and 1. Okay, when you paste that in there and press enter, okay, and I'm expecting a little more than 50%. So this is approximately 0.5675, which makes sense to what my graph is showing.
Where are you getting the 5 for that? Because when I punch it in, I get 0.06749.
So are you putting exactly this in?
Yes.
I think you're putting something in different. So let me walk you through it again. So go second VARS.
Yep.
And then did you do normal CDF, not PDF? You did number 2?
Yeah.
Okay. And then negative, not your subtraction, but negative 0.17.
Yep.
And then 1, and you do capital, not negative 1 because it's positive infinity now.
Yep.
So 1 and then second comma is your E, 99. And then you have 0 from you and standard deviation of 1.
Yep.
Okay, so let me show you what I have.
Yep, that's what I have.
Okay, and then you press enter and it comes on your screen. Let me clear this out and do it again. Okay, so now on your screen you have that.
Yes.
Press enter again.
Mm-hmm. Yeah, that's not the same number I get. Let me see.
So I'm not sure what you're punching in different.
I am not sure.
Show me your calculator.
The last one was not, I did not get the same answer either.
Okay, show me your calculator. Can you move it down a little bit? Okay, go ahead. I saw it. Okay, never mind. I see it now. Okay, and then do that again. I mean, sorry, just like
there it is.
Evaluate.
Yep. It went.
Did you get it now?
Yep.
You got it? Okay. Okay.
I don't know what I did wrong the first time.
Yeah, I mean, I'm just kind of guessing what it could be, but.
Really quick, how do we get the E on the calculator again? Comma.
Second comma.
And where's the comma?
Above the 7. Your 7 is above the 7. There's a comma. On your calculator, it's right. So the 7 is here. 1, 2, 3.
Oh, look at that. Okay.
So right above the 7 is that button right there.
And then so 1 comma.
No, so you would have, you're just trying to, when you want the EE that is above the comma.
Oh, okay, got it.
So you hit second and then comma, and that gives you the E on your screen.
Perfect, got it.
Okay. Okay, so drawing the diagram is important because it connects with what you would expect your calculator to output. So if you got like, on this one, if you got like 30.3, you know that you did something wrong because it's more than 50% of the area. You're shading more than half of the area under the curve. So you know what to expect based on what your graph looks like. Okay, so let's go ahead and go on to part C, which is the next page. I don't know how much time I want to spend on this, but yeah, we can do this. Okay, so let's do this one. draw your diagram first. And let me just go back. I didn't write probability statements, so I actually want to go back and just be clear, a little bit more clear about that. So I'm going to come back here. So my probability statement for, I'm going back to this first part again. Change the color here. So area to the left, my probability statement is going to be the probability that Z is less than 2.14. So that's what we're finding. We're finding the area where Z is less than 2.1. So that's my probability statement. So on this next one, this would be the probability that Z is greater than negative 0.17. Because we want to the right, so greater than negative 0.17. So my probability statement, my graph, and then my probability. So now on this one I'm trying to get to. Okay, so the area between would be the probability that Z is between 1.09 and 2.11. So when you draw your graph, this is the Z-score, so I know my scale is 0 in the middle, and then the negative 3, 2, negative 1, and 0, 1, 2, 3 to the right. So now I can mark on my graph 1.09, and I can mark 2.11, and I want the area between. So your calculator command, normal CDF, the lower is 1.09, the upper is 2.11, the mean is 0, and the standard deviation is 1. Okay, so the calculator can be really efficient, just as much as StatCrunch can be. And the calculator is great, StatCrunch is great. We're going to do both today. If you were doing this with the tables, you would have to look up 1.09, look up the area to the, you probably would look at the area to the left of that, then look up 2.11, look at the area to the left of that, and then do some subtraction. So you don't need to do that. You can use your technology and say, I want between these two numbers. Okay, let's try this one. I'm going to give you a moment to draw the picture out. Part D, area to the right of Z equals 3.05 and to the left of Z equals negative 1.68. So if you're looking at your graph, is that what did you draw something similar to that? Okay, so if I'm going to write my probability statement, it's got to be actually two probability statements because I'm going to have to add these two areas together. The area to the left of negative 1.68 and plus the area to the right of 3.04. So the area to the left is the probability Z is less than negative 1.68 plus the area to the right where Z is greater than 3.05. Okay, so do you see that those two pieces add together would give you your answer? But do you also see that if we found the area inside here, where I did the big X, if I found that middle area and I subtracted that middle area from 1, I would get those end pieces. So if I went 1 minus the probability that Z is between those two end, whoops, lost my lesson sign. Running out of room, so let me scoot it over just a little bit. So if we went 1 minus, and I'm looking at the area in between negative 1.68 and 3.05. So if I find where I put that blue X, if I found that area and I subtracted from 1, I would get those tail pieces. And then I only have one command to type in. Otherwise, I would have to do it twice. I would have to look at the area, the left tail area. I'd have to look at the right tail area and add those together. But I can do it this way all in once. And actually StatCrunch is set up this way for you as well. So I'm going to put on my screen, I'm going to go 1 minus. Before I go and grab the normal CDF, I'm going to put the 1 minus on my screen. And then I'm going to go second vars, grab your normal CDF. I want between negative 1.68 and 3.05 for Z-scores, the mean is 0, standard deviation of 1, and I hit enter. So it comes on my screen, and when I evaluate it, I get approximately 0.0476. And that's my answer. That's not the area in the blue because I've subtracted from 1. So my probability of the two ends together. So that's a way you could use like the complement, where the total area under the curve is 1 or 100%. And if I subtract out the middle, I end up with those tail ends. That would be more efficient. Okay, can we move on? Okay, so this is not on your handout, but here are 3 ways that we interpret the area under the curve. So if you want to write this in your notes, because we're not doing any of this by hand. So we didn't do any of those calculations by hand. We just use a calculator. On the next set, I'm going to use StatCrunch, okay? So one way is with probability. And those are the words that I was using pretty much for everything, the probability. So the area under the curve represents a probability. And it's the probability of a randomly selected individual from a population with a certain characteristic. Let's see if I can write that better. From a population so sorry for the sloppiness. Probability of a randomly selected individual from a population with a certain characteristic. Okay, we could think about the interpretation of the area under the curve that way. A second way is to think about it as a proportion, because you're asked to find the proportion. It's similar to probability. So the proportion would be the proportion of a population with a certain characteristic. So you're looking at a probability of a randomly selected individual with that characteristic, or you're looking at a proportion of the population with that certain characteristic. And then a third way to consider area under the curve is to think of it as a percentile. And we're going to do an example of all of those 3. Okay, remember percentiles, that's the location where the percent is below that. So if your child is in the 90th percentile for weight, your child is heavier because 90% of the population would be lighter than your child. So it's always the area to the left. Percentile represents the area to the left in the diagram. Okay, we're moving on. I've already written this out just to save time. So we are going to go backwards. We are now going to try to find the z-score and not just, we're going to find the z-score based off of the given area. So find the z-score such that the area to the right is 0.025. Area to the right. So I'm going to draw my diagram here. And I want the area to the right. So this is what I know. I know this area is 0.25, 25%. I am trying to find this location on the number line. What is this location? What is this position on the number line? This position on the number line, what is that position that gives me 0.25 to the right? That's my question. We can do this with a command in the same place as second vars. It's called inverse norm. So if we go second vars and you go to inverse norm, it asks you for the area. So I want you right now to put in 0.25. So put in 0.25 for the area. Okay, so can you see my calculator? So this is what I'm asking you to do. So under second vars, select inverse norm, and then put in 0.25 for the area. Okay, paste that in, press enter, and what answer do you get? Don't you get this answer right here? It's a negative. My answer is negative 0.67448987, etc. So my answer is negative. So I put in area 0.25, but your calculator is thinking of this area. But you know that negative 0.67 is not the answer because 0.25 to the right, if 0 is in the center on this number line, then I know I'm looking for a positive number. I'm not looking for negative 0.67. That would be to the left of 0. Positive 0.67 is what I want. So I can use symmetry. So if I did inverse norm and I put in 0.25 for the area, 0 and 1, I'm going to get negative 0.67. So I'm actually getting this area and I'm getting this value. So I can use symmetry knowing that a curve, a standard normal curve, is symmetric. So if I have negative 0.67 on the left, then positive 0.67 would be on the right. Or I could put in 0.75 instead of 0.25. And doing this is so much easier on StatCrunch, so I don't want to spend very much time right here about finding the area. Given the area. So you're given the area and you're trying to find the z-score. StatCrunch works really well for this case. So I don't want to spend too much time here, but you know the symmetric curve of a standard normal. So if you put 0.25 in and you got a negative z-score, you know that that is the left z-score, not the right z-score, because the right is a positive value based off of the location. If the middle is 0, then I know if I go to the right of 0 on this number line, remember this is a number line. So on this number line, to the right of 0 would be a positive value, not a negative. So I should be getting that positive value, 0.67.
But on the calculator, you can switch it to whether you're looking for the area of the right tail or the left tail well, which will give you the correct number.
So some calculators are updated for that, yes. And which is awesome. That's a good improvement for the calculator because it's very confusing on which one you're supposed to, or which format you're supposed to put in. So that's great. Your calculator does that. So you can definitely choose. That's good. Okay. I'm going to go on. I'm going to get off of part B and we're just going to go on. We're going to move forward. Yeah, we're going to move forward. Okay, so let's go into, so I'm just skipping down to this. This will be one of your next slides. We talked about probability. Now I want to talk about the percentile. Remember, the percentile represents the area to the left. I just talked about that a minute ago, of the specific value. So assume the random variable X is normally distributed with the mean given to be 50 and a standard deviation of 7. So if there's a mean of 50 and a standard deviation of 7, this is not a standard normal, right? So now we're looking at X with the normal distribution where the mean is 50 and the standard deviation is 7. So when I draw my normal curve, I put 50 in the middle. I don't put 0 because we're not on a standard normal, we're on just a regular normal distribution. So now the middle is 50. Okay, we want to find the indicated percentile. So the 9th percentile means the area to the left is 9%. So shading this area would represent 9%. We are trying to find what is the location on that number line that gives me 9% of the area to the left. So we could use our calculator, inverse norm. We put in area of 0.09, area to the left. You put in the mean and the standard deviation, and you get 40.6. So this is going to give you the value. The percentile is 40.6. It's the 9th percentile, which is the location of 40.6. Okay, so I know a lot of you use the help me solve this or similar example, and I wish that I could turn some of those functions off because they do take you into actually how to solve that using a z-score. But I'm asking you, please don't do that. It's just a waste of time because we have so much technology. It's just more efficient to use StatCrunch in your calculator than to try to solve. What you're doing is you're calculating a z-score and then you're going backwards and using a table. So it's not as efficient and not as accurate. Okay, so the 85th percentile, let's do this next one. 81st, sorry, the 81st percentile. So we draw our normal curve. It's the same distribution, so 50 is in the middle. And we want 81st percent. So the 81st percentile means 81% to the left. 0.81 to the left is the area. And you're trying to find what is this location? That's your question mark. What is that location that separates the 81% to the left and the rest to the right? So we can use the inverse norm again, 0.81 for my area, and then we get a value of 56.1. Okay, we're going to go on to the next slide, and I'm going to do this one with the calculator, and then I'm going to do the rest of them on StatCrunch. So this is the last one I'm going to do on the calculator. So let's just read the paragraph. Chips Ahoy cookies, the number of chips in the 18-ounce bags of Chips Ahoy chocolate chip cookies is approximately normally distributed. Okay, so it gives us the kind of distribution it is. You're going to learn another kind of distribution called the T distribution. You're going to learn that soon. But this is normally distributed. It gives you the mean and it gives you the standard deviation. Okay, so from that, I'm going to write my information that X follows, the random variable X follows a normal distribution with the mean and the standard deviation. I write this down. I learned this when I was in graduate school, maybe undergraduate. I can't really remember when I learned it, but it's always something that, you know, when you're trying to solve problems, it's just information I write down immediately at the top of my page. So I know the random variable it's representing, I know the kind of distribution it is, and I know the important parameters. So I just do that automatically. The people that give you the lessons on the interactive lessons, I don't know if they do it in exactly that form, but this is kind of just what I do. So I'm just giving you a tip from me. Okay, so draw the diagram for each and shade the appropriate area and then calculate the probability. So what is the probability that a randomly selected 18-ounce bag of Chips Ahoy contains between 1,000 and 1,400 chocolate chips inclusively? So the first thing that I'm going to do is I'm going to get another page here. Okay, so what I want to do is I want to first draw the diagram. And I have the answer written out here because I was trying to just save time, but my iPad's just freezing on me. Here we go. Okay, there we go. Okay, so we know on this curve, the center is 1262 because that is the mean. Okay, so if I add one standard deviation, so the standard deviation is 118. So if I take 1,262 and I add 118, I'm at 1,380. Okay, and I'm just going to stagger these so I can fit them in a little bit easier to see. Okay, now if I add another standard deviation, so I add 2 standard deviations to 12,000 or 1,262, I get 1,498. And then I'm going to take it out one more because I like to go 3 standard deviations out, 1,616. I'm going to go the other direction, so I'll subtract a standard deviation from the mean and get 1,144. I'll subtract another standard deviation, 1,026, and I'll subtract one more time. So this is the diagram for the normal distribution of these chocolate chips with the mean of 1,262 and the standard deviation of 118. Okay, so I'm going to use this diagram for all of my problems. Okay, this problem says find the probability that the number of chips is between 1,000 and 1,400. So I would mark on my graph 1,000 would be about right here. Okay, on the number line, 1,400 would be over here. And then I would shade the area in between. Okay, did you write your probability statement? So write your draw the diagram, shade, and then write your probability statement. So probability that X is between 1,000 and 1,400. That's your probability statement. And then you're going to use the technology. Okay, so your technology would be normal CDF, 1,000 is your lower bound, 1,400 is the upper bound. You got to put your mean in different now because it's not a z-score. You're given the mean to be 1,262 and the standard deviation of 118. And then you get your end result. Okay, questions on that? Okay, we're going to go on and I'm going to change my screen so that we can get to StatCrunch. But I want you to first draw the diagram for part B here. So what I'm asking you to do is draw the diagram for this part. Draw the diagram, draw the shading, and write the probability statement. Okay, when you're ready, look at what I have on the screen here. Oops. Lost my numbers there. Okay, look what I have on the screen there, and then compare with what you have. So I just asked you to draw the diagram. We're going to do all the calculations in StatCrunch. So is this the diagram that you have? And then probability statement as well. Okay, do that now do this now for part C. And notice part C, I'm using a different word. What proportion? So in part B, it was what is the probability that a randomly selected, okay, so the randomly selected bag, this is what proportion of the bag. So just different words, but still same idea. Contains more than 1,200 chocolate chips. So write the probability statement and change it there. Okay, we're going to go into StatCrunch now and do both of these. So I'm going to stop sharing this screen. And I have it in here somewhere. This way. Oh, whoops. Okay. Come back. Okay, can you see StatCrunch on your? Okay, thank you. All right, so the first one we did was, what is the probability? Let's go to part A. So let's go all the way back to part A. Part A is what is the probability that a randomly selected 18-ounce bag of Chips Ahoy contains between 1,000 and 1,400 chocolate chips inclusively. So I go to stat and then calculators and I go to normal. Okay, and then I get this on my screen. So it's already got the diagram. We want to choose between, so this is for part A. We want to choose between. I want to come down to mean and I want to put in 1,262. I want to put the standard deviation of 118. So that's what's given, the parameters that are given. The probability that X is between 1,000 and 1,400. And then I hit compute. Okay, and then my probability is what the calculator also gave. So StatCrunch is really efficient and it gives you the graph as well. So being able to connect that graph with the visual of the probability is really valuable. Okay, so let's go on now to the next one. The next one was part B. Part B says, the probability was a probability that a randomly selected 18-ounce bag of Chips Ahoy contains fewer than 1,000. So I need to go back to standard. I'm going to click the standard box, not the between. The mean and the standard deviation are given, so that's the same. I need to choose the direction of the inequality. So we want fewer than, so this is correct, less than. And then I'm going to type in 1,000. And then I'll hit compute. Okay, so that diagram matched the diagram that I wrote on my paper. So I knew that I've double checked that to make sure that seems accurate. So the probability is 0.0132, rounding to 4 decimal places, 0.0132. And then part C says, what is the proportion of 18-ounce bags that contains more than 1,200 chocolate chips? So proportion, I'm still going to use standard because I'm looking at more than. So I'm going to change the inequality to greater than, and I'm going to put in 1,200 chips and then hit compute. Okay, so this is amazing. StatCrunch is awesome when you start realizing all of the pieces it puts together immediately. But being able to interpret it is really necessary and important. Let's go on to part D. We just did C. I don't think we need to do, I think D, we can skip D. Let's go to part E. So part E on the document says, what is the percentile rank of an 18-ounce bag of chips that contains 1,475? Percentile is the area to the left represents the percentile. So I know that I'm looking at less than. So I'm going to change my sign to less than. And then I want the percentile rank of 1,475. The mean and the standard deviation is the same because it's the same problem we're given. So the percentile rank is, and I would round that to be 96th percentile. So approximately the 96th percentile, 0.9645, which would represent a probability. So the percentile would be 96th percentile. Okay, and then part F, what is the percentile rank of an 18-ounce bag? Chips Ahoy contains 1,050. So the percentile rank for 1,050, compute, and there we go. So the percentile rank here is 0.036. So I would probably round that up to 0.04, which would be the 4th percentile. Okay, so a couple things to note. The scale on the StatCrunch is not the scale that we've been drawing. The scale that we have been drawing on our diagrams is specifically identifying the mean and using the little marks, the scale that goes out with the standard deviation. So pay attention to the scale that the graph is given you in StatCrunch, and know that when you draw it on your paper that you should use the scale of the mean in the middle and then the standard deviation that goes out, like we've been demonstrating all morning or afternoon, whatever it is. Okay, the last little bit, I'm at an hour right now, but I would like to take just a little bit more time and do this last problem. So the last problem is we're working on, we're going backwards a little bit. So determine the 30th percentile. I'm sorry, let's read the whole thing. So the whole thing, the paragraph is still the same situation, the same number of chocolate chips in the 18-ounce bag that's normally distributed, the same parameters are given, all of that is the same. So on number 49, if I go down to part A, it says determine the 30th percentile for the number of chips in the 18-ounce bag of Chips Ahoy. Okay, so that's different than what we just found. We were given the percentile rank and we were trying to decide what the percentile was, but now we're trying to find, we're given the percentile and we're trying to find like the rank of it. So you want to draw your diagram, and I'm going to go back to my, I'm going to go ahead and go back to my iPad so we can get this set up. So I'm looking at part A. Oops, not let me do that, sorry. Okay, here we are. So I'm looking at part A here. The mean is 1262. And I'm not going to put any scale on because I'm not really sure where it's going to fall. But I know 30th percentile, I know this area right here is 0.30. So the area is 30th percentile would be to the left. And I'm trying to find out what is this location on my number line. That's my question. What is that location on the number line? So we can either do the inverse norm on the calculator, or we can go into StatCrunch. It won't take me too long to flip back and forth here now that it's open. Okay, so in StatCrunch, I know the area, but I don't know the location. So I'm going to erase where my probability statement has less than or equal to 1050. I'm going to erase that part. Okay, and then I want to put in the area to be 0.30. So I know the area, but I'm trying to find what is the location. I'm making sure it says less than because I want to know the area that's less than, but I'm trying to find what percentile that is. So now if I hit compute, it's going to fill in what the value is, which is 1,200. So the percentile for the 30th percentile is 1,200 chocolate chips. If we move on to part B, determine the number of chocolate chips in a bag of Chips Ahoy that makes up the middle 99%. So now I want to choose the between option. I don't know these values. I don't know the values that make up the middle 99%. I know the mean and the standard deviation of the population. It's already been set. But I want the middle to be 99%. So I want the resulting area between the values I'm trying to find to be 99%. And if I hit compute, it's going to pop in the values. So approximately 958 chips, between 958 chips and 1,566 chips by rounding. So this middle area is 0.99 or 99%. Okay, happy with that? We're on the last question here, which is part C. So I'm going to come back into my iPad. Okay, so now we're trying to find what is the interquartile range. Interquartile range, remember, we abbreviate it with IQR, is the difference between the third quartile and the first quartile. Okay, so now I have to think about what the quartiles mean as far as percentiles. So remember on the 5-number summary, we had the minimum, we had the maximum, you have the median in the middle, you have the first quartile, and you have the third quartile. So, and if you're thinking about a box plot, remember our box made up that. Okay, so this is a location. This is a location type of question because Q1, okay, let's look at median first. So the median, that's the middle as far as location. If we listed the data in order, we would choose the middle value. So 50% of the data would be to the left of the median. So the median would be the 50th percentile. That's the median. So what is the first quartile? The first quartile would be location here. And what does it separate? So isn't it the middle of the first half of the data? So it's smack dab in the middle of the first half of the data. So this would be 25%. Let me brighten something darker. Do orange. So we'd have 25% of the data to the left of the location of the first quartile, which would be the 25th percentile. Okay, so the median is the 50th percentile. The first quartile would be the 25th percentile because 25% of the data is to the left. Okay, so think about the third quartile. So doesn't it separate the top half? So how much of the data is to the left of that? So the median is 50% because it's right in the middle. So 50% of the data is to the left. The first quartile, there's 25% of the data to the left. So the third quartile, wouldn't that be 75% to the left or the 75th percentile? So we're going to use the ideas of percentiles so that we can identify the third quartile and the first quartile, so we can ultimately answer the question, which is asking us to find the interquartile range. What is the interquartile range? So this interquartile range, we need to know the third quartile, we need to know the value of the first quartile so we can subtract them and get that. So that's where we're headed. So let's draw some diagrams. So here's your Chips Ahoy. We've got the 1,262 for the mean. I'm not going to put standard deviation scale on yet because I don't know where that is, but I do know that 0.25 by shade, 0.25 area, I know that that's the first quartile because it's the 25th percentile. So how am I going to find that? I need the location and I'm given the area. So you can use your inverse norm or you can go to your StatCrunch. Right? In StatCrunch, we'll go into that in a minute, but in your, let's do inverse norm. No, let's not do that because I have notes on that. I can show you in a minute, but in StatCrunch, you would go and you would look at probability. We only want X. Let's see, how do they do that? Like this. Okay, the probability, the X, and then we would choose less than. So we would choose that less than. And then we would have whatever blank this is. We don't know the value. That's what we're trying to find. That's what we're trying to find, that Q1. And then it equals, so in this box, we would type in 0.25. So we know this, we need to choose the less than because we want the left area. And then we don't know what that first quartile is. Okay, and then I think it should come out to be when you hit compute, so then you have to do compute. It comes out to be 1182. So that's the first quartile. To find the third quartile, so for the third quartile, so this is Q, this would be Q1. You try to draw your diagram for the third quartile. Okay, so 75% to the left of the third quartile. That's what we're trying to find, the location. What is that location on the number line? That's what we're trying to find. What is that location? 75% area to the left. So I know that I would enter in the area 0.75. I would make sure I'm choosing less than because I want the area to the left. And when I hit compute, somewhere here, when I hit compute, so you have to make StatCrunch evaluate that. I should get 1342. So this is what your third quartile would be. So the interquartile range, which is Q3 minus Q1, that distance is 1342 minus 1182, which is 160. Okay, so it's real. I can get into StatCrunch pretty quick here. So what we did was we need to choose standard because we only want one, either the left tail or the right tail. The mean and the standard deviation are the same. I'm making sure I have less than, and then I don't know what the value with the first quartile is, but I know that 0.25 is the 25th percentile or 0.25 area. So when I hit compute, I get 1182 approximately. I do the same thing, but this, I'm going to put 0.75. I don't know the number. I want less than that number to give me the 0.75, and I have 1342. I round it up to. So then I would subtract those quartiles and get my answer. Okay, so that is really all that I had planned to cover today, and we are a little bit late. We're about 15 minutes over, so I don't want to stay too much longer.
How would you do that on a calculator?
How would you do it on the calculator? Oh yeah, I was going to show you this. Sorry. Thank you for that. Okay, so I did. Okay, so I'm going to show you, I wrote this out on calculator. So if you're watching this again, or if you know right now, you can just go to the end of this video and be able to pull this up. But this is how I calculated with the calculator. So everything on here, I just copied my notes. So this was part A, and I did that with the calculator. This is part B. Here's part C, the calculator, part D, the calculator. So you can go back and pause the video. So the percentiles also with the calculator. This is part E, the calculator. And then here's the one we just did. So the 30th percentile with the calculator was the inverse norm. For the second one, when you do the middle, and Kayla, you said your calculator, you can choose middle. If your calculator doesn't choose middle, then you have to find each of these separately. So that's what I did. And then here's the third quartile for the calculator. So each of these separate. Find the 75th percentile, the 25th percentile, and then subtract. So if you want the calculator commands, go back to this part of the video and pause it, because those were the notes that you can see for that last question, or the question before this one at least. Okay, anything else for me? Any other questions? No? Okay. All right, so I hope that you can still continue with stamina and energy to get through the last few weeks of the quarter. We're really close. This is when everything it's just really getting so much better. You're going to see, I promise you're going to see this come full circle, and then you're going to move forward and be able to apply this in your real life, which is very exciting and makes my job worthwhile when that happens. Okay, everybody, have a lovely rest of your day. Talk to you later. Bye.